Hi everyone. Let us solve this example of power series. Okay, what we have to prove, it's a very simple thing we have to do. This is a series they have provided and we have to prove that their sum is 1 upon 1 minus x. Okay, so first of all I will write the given series. Okay, so I wrote the series. So after that I will write the Cn. Cn means coefficient of x raised to n. But see here coefficient of x raised to n is 1. So that's why obviously Cn is equal to 1. Okay, so after that I will go for the radius of convergence. So you know that there are two distinct formulae to find radius of convergence. Okay, so out of that one formula I'm going to use. See this formula 1 upon limit n tends to infinity mod Cn plus 1 upon Cn. But see what is Cn here? 1. So obviously Cn plus 1 is also 1. So 1 upon 1, 1. So it's obviously denominator is 1 we get and it is equal to 1. So that means radius of convergence is 1. So that's why we can say the given series, this series is convergent for mod x less than 1. So this convergence is uniform convergence for the radius of convergence. So that's why at the end I mentioned uniformly, since this convergence is uniform convergence. After that, what will I do? I will consider the sequence of partial sum. Here we are denoting sequence of partial sum by Sn. Okay, so therefore Sn of x is equal to, okay, so that means I will put n is equal to 1, 2, 3 up to n. That means up to a particular number n. So we will have, see, Sn means sum of first n terms. Okay, so by considering 1, you can go up to x raised to n minus 1. Do you know this is expansion of what? This is expansion of 1 minus x raised to n upon 1 minus x. So that means in simple way words we can write Sn of x is 1 minus x raised to n upon 1 minus x. So now I took the limit of both sides. Okay, so when I take a limit of both sides, here mod of x is less than 1, so that's why when you take a higher power it will go to 0. So that's why you will, at numerator you will have 1 minus 0 and denominator will be same 1 minus x. In bracket I mentioned that mod x less than 1, so it is 1 minus x. Okay, so see, so this is a limit of sequence of partial sum. Therefore sequence, that series also converges uniformly to same function with a given condition mod x less than 1. So that's why I wrote the same. Therefore series converges uniformly to 1 upon 1 minus x for mod x less than 1. So therefore this is nothing but same. Both of them are equal. Okay, in this way we proved. Thank you.